In this lesson, we're going to look at the queue data structure. We already covered a type of queue earlier in the course when we talked about priority queues. Now we're going to look at just a very standard queue implementation. But we're not really going to use a queue class. We're going to use another built-in class that's already part of the Java library, the linked list class. And we're going to narrow down the linked list to just a couple of methods that we're going to use. And then in the exercises, I'll demonstrate a use of using a pure queue class. So let's get started. We're going to call this program name queue because we're just going to put some names into a queue. Keep the instruction on this simple. First thing we need is our linked list class. And before we start, let me talk a little bit about what a linked list is. A linked list is just a data structure where each element is linked to the other element. A lot of times we call those elements nodes. And in fact, we're going to look at nodes in the next lesson on binary trees. But a node is simply an object that has room to hold data and pointers, either to an object that follows it or also to an object that precedes it. A singly linked list is a linked list that has pointers to the nodes that follow it. A doubly linked list is a list that has nodes that have both forward pointers and backward pointers, succeeding and preceding pointers, if you want to look at it that way. But we're not going to worry about that. We're going to simply use our linked list to talk about queues. So let's talk for just a minute about queues, although we should already be familiar with them. A queue is a data structure where the data goes in at the back and goes out at the front. Again, we think of a line at a grocery store or the line at a bank as an example of a queue. So what I'm going to do in this lesson is show you the methods that you need to operate a queue or to write a program using a queue. And then in the exercises, we'll look at an example. Here we're just going to simply put names into the queue to demonstrate how they work. So the first thing we have to do is instantiate our queue as a linked list. So we're going to write linked list string names equals new linked list string open close parentheses. As I mentioned earlier, data is always added to a queue at the end. So the method that we use is add last. So add last will put the name in at the end of the queue. So let's add a few more names. Write a for loop to go through the names just to display what's in the linked list. So we'll write our for loop like so, using the standard format we've been using. Here we'll simply print them out one name per line. Let's close out the program, save it, and compile. And then we'll run it. And there are our names. So, adding data to a queue is performed with add last. To remove a name, we use remove first. And we don't specify a name, we simply say remove first, and the first name, the name at the head of the queue, is removed. So let's take a look at that. So we'll remove one name, and then we'll display the queue again. Save it. Let's clear the screen. Compile it, and then run. So we had Cynthia, Raymond, David. Now we just have Raymond and David. Now let's add a name into the list again. Then we'll print it out again to see where that name comes into the queue relative to the names that are already there. And what we probably need to do is after each one of these for loops, we need to add a blank line just to make it easier to see where we're displaying information. Let's run again. So we'll compile and then run. Okay. So you see that we started out with Cynthia, Raymond, and David. Cynthia was removed from the line. Clayton was added, and see that Clayton goes in at the end, and Raymond will be the next name that is removed. We can also look at the size of our queue, how many elements are in it, using the size method. Let's take a look at that real quick. Compile and run. We have 3 names in the queue currently. And then finally, we can also check to see if our queue is empty and only try to remove if our queue is not empty using the isEmpty method. So we can say if not names is empty, and let's display the size again. Let's clear the screen first, and we'll compile, then run. So we used our isEmpty method to make sure that the queue was not empty, and it wasn't, so we removed Raymond from the list, and we can verify that by using our for loop again. We'll compile, then run. So you see that now we're down to David and Clayton. So those are the fundamental methods you'll use with the queue. Now, they're certainly not all the methods that are part of the linked list class. But what I was trying to do was minimize the interface to just those methods that are typically used with the queue. And even those are not all the ones that are used, but the ones that we're the most interested in. So we're ready to move on to the next lesson where we're going to talk about binary trees, and we'll come back to queues in the exercises where I demonstrate a different use for queues than we saw in the previous chapter with priority queues.